Hello guys, welcome on Tesla Adventures. In this video today we'll going to discuss the self energy of spheres, hollow and solid. If you remember in the previous video of potential energy, I have already discussed that there are two types of potential energies. One is the interaction energy and other is self energy. So I told there that we are going to discuss interaction energy in this video, and we are going to discuss the self energy in the other video. So now we are going to discuss the self energy. So what is self energy? So you can imagine that, just imagine that this is a hollow sphere and it has some mass m. Now this hollow sphere is a complete unit. It is a single quantity, which we say that it is a single hollow sphere. Now it is an extended mass also, because it is not a point mass, so it is an extended mass. And you can see that the complete mass of this hollow sphere is m, capital M. Now we can imagine that the complete mass capital M, which is an extended mass, extended mass can also be regarded as the sum of small point masses. So we can imagine that we are assembling the point masses, infinitely different number of point masses in form of a spherical shell in such a way such that all are at an equal distance from the center O. So that would create completely a hollow sphere. So the energy or the work done which we have done in assembling this sphere from infinity is equal to the self energy of this sphere. Now why it is regarded as self energy, although you can see that it is also an interaction energy of infinitely different point masses which are assembled on the circumference of this or the surface of this sphere. But they all together are a single quantity, single entity, which is a solid sphere, which is a hollow sphere in this case. So that is why we are referring this work done of R as self energy of this sphere and not the interaction energy, because we are referring this complete sphere as a single body or single entity. So now how do we find out this self energy? So let us imagine that we are assembling the masses from infinity. Until some time t, we have already assembled small m mass. Now we are bringing additional dm mass from infinity, and we will perform some work done in bringing that dm mass. That work done would be equal to m delta v, m dv or m delta v, where m is the mass which we are bringing. So we are bringing dm mass, and delta v is the potential difference between the final point and the initial point. So the final point is the surface of the sphere, and we know that the potential on the surface of the sphere will be gm by r with a negative sign, and initial point is infinity, their potential is 0. So dw is equal to minus gm dm by r, and the total work done will be integration of minus gm into dm by r. The limit of this m would be from 0 to capital M, because the total mass of this hollow sphere was capital M. So the work done will be equal to minus g by r, and this is m square by 2, and limit would be from 0 to m. So this work done is equal to the self energy of this sphere, and this is minus gm square by 2r. So this is the self energy of the sphere, hollow sphere, and we know that it is also a form of a potential energy. So the potential energy is always stored in the gravitational field or the field associated with that energy. So here we are discussing the potential energy of gravity or the gravitational potential energy. Therefore, we can say that this gravitational potential energy will be stored in the gravitational field itself. So you can say that this is the self energy of the sphere, hollow spherical shell, which is the potential energy, and this potential energy is stored in the gravitational field, and the gravitational field inside this sphere is zero. We know that the gravitational field inside the hollow sphere is zero, and the gravitational field is only outside this sphere, like that. Okay, so this is the gravitational field, and therefore we can say that the self energy of this sphere, which is minus gm square by 2r. This is minus gm square by 2r, capital M. So this self energy is stored only outside the sphere, stored from surface to infinity. It is not stored inside the sphere, because inside the sphere the gravitational field intensity is zero. Okay, so this is the self energy of a hollow spherical shell. Now let us find out the self energy of a solid sphere. So we know that this is a solid sphere and the complete mass is distributed uniformly inside its volume. So let us imagine that at some point of time we have only assembled a sphere which has a radius small r, and the mass of this sphere would be m. So this m will be equal to the density of the sphere, rho, into the volume. Volume will be 4 by 3 pi r cube. And the potential of this sphere on the surface, V surface, will be equal to minus gm by r. So V surface will be equal to minus g by r into rho into 4 by 3 pi r cube. So V surface will be equal to minus of rho g into 4 by 3 pi r square. Okay, so this is V surface due to this shell. Now we are bringing additional shell from, we are assembling this additional mass dm in form of a shell around this sphere, solid sphere, like that. So we have brought a dm mass from infinity, and we have distributed this dm mass around this shell. So the work done, first of all, dm, the value of dm will be equal to dr. Let's suppose this width is dr, so dm would be dr into 4 pi r square. This is the elemental volume, into density is rho. Okay, so work done will be equal to dm into delta V, where delta V is the final potential minus initial potential. So work done dw will be equal to dm, which is dr into 4 pi r square rho, and delta V is the potential difference between final point and initial point. So we can see that the final point will be this point and the initial point is infinity. So the potential at this point is already, we have written that it is equal to minus of rho, this is minus of rho into g into 4 by 3 pi r square, and the potential of infinity is 0. So we have not written that. So you can see that this is the small elemental work done, and the total work done will be equal to the self energy, U self, and it would be equal to integration of dw So it would be equal to, I would take out all the constant terms outside. So it is 4 pi rho into 4 pi rho divided by 3. So it would be 4 pi rho whole square divided by 3. You can see that this is 4 pi rho and this is 4 pi rho and divided by 3, and g is also the constant term, so it is also taken out and there is a negative sign. Okay, and inside the integration it would be r to the power 4 dr. So it would be r to the power 4 dr. Okay, u self will be equal to minus g into, let us multiply and divide with 3. So this is 3 and this is 4 by 3 pi rho whole square, and this is g, and this is r to the power 5 by 5, and limit would be from 0 to r. So u self will be equal to this is 3 by 5 g, and there is a negative sign. Now you can see that the value of m, which is the mass of the sphere, is equal to 4 by 3 pi r cube. Okay, and this is the capital R into rho. So what we'll do, we'll write it down as m square by r. You can see that 4 by 3 pi rho and into r cube, this would be r to the power 5, and we would multiply and divide with r. So there would be r to the power 6 term on the numerator, and it would make this m square, and there would be r. So u self of a solid sphere is minus 3 by 5 gm square by r. Now we know that solid sphere has the gravitational field both inside as well as outside the sphere. Therefore, this self energy is stored both inside and outside the sphere. But we know that the formula of gravitational field and the gravitational potential of solid sphere and hollow sphere outside the sphere is same. Therefore, we can say that u self for a solid sphere is u self out plus u self in. And we know that u self total for a solid sphere is minus 3 by 5 g m square by r, and u self out, the self energy stored outside the sphere, is same as the self energy stored outside the hollow sphere, and which is equal to minus g m square by 2r, and this is u self in. So u self in can be calculated by minus 3 by 5 g m square by r plus g m square by 2r, which is equal to minus g m square by 10r. So this is the self energy stored inside the solid sphere, and the self energy stored outside it is this one, and the total self energy is this one. So this was the self energy of this sphere, and let us solid sphere, and let us also analyze that if there is a mass m kept inside this sphere, spherical shell, then the total energy of this system will be equal to u interaction, which is the interaction energy of this small mass m and this spherical shell, plus u self of shell. So U total will be equal to, U interaction will be minus GMM by capital R, okay, and U self of this spherical shell is minus GM square by 2R, okay. And if in case, if in some problem, if you are seeing the two concentric spherical shells like that, its radius is A and its radius is B, its mass is m1 and its mass is m2, so U total in this case would be equal to U self 1 plus U self 2 plus U interaction. So U total would be minus G m1 square by 2a minus G m2 square by 2b and minus G m1 m2 by b. You should always remember that while we write the interaction energy of two concentric spherical shells, then the distance is always taken as the radius of the bigger sphere. And you can also derive this expression by integration of their self energies. Okay, so this is the case of self energy, and in the next video we'll be going to discuss the gravitational potential energy of Earth. Thank you.